Hi guys, now we are going to be discussing communication system level 2 questions. 14th question. A 1000 kHz carrier is sinusoidally modulated with 300 Hz, 800 Hz and 2 kHz audio waves. The frequency present in the output are. They have given that frequency of the carrier wave 1000 kHz and 3 audio signal waves, that means FM1, FM2 and FM3. Frequency of the audio signals they have given is 300 Hz, 800 Hz and 2 kilohertz. This 300 Hz means in terms of kilohertz means 0.3 kilohertz and 800 Hz means 0.8 kilohertz and FM3 is already 2 kilohertz they have given. The frequency present in the output are, that means FC is going to be modulated with FM1, FC is going to be and FM3, and whenever these are going to be modulating, what are the outputs? We know that modulated signal we can give like this. In the modulated signal, one is the carrier wave FC is present and also another one is FC plus FM upper sideband frequency USP and another lower sideband LSB. This is LSB, lower sideband frequency, and this one is FC minus FM are present. That means one frequency, another frequency, these are the frequencies are present, and FC amplitude is AC and lower sideband, upper sideband frequencies amplitudes are mu AC by 2. That means amplitude of the upper sideband is M into AC by 2. AC means amplitude of the carrier wave, M means modulation index divided by 2. And this is the FC, LSB or USB amplitudes. Now we have to find this FC plus FM and FC minus FM. And if you do these two things, FC plus FM1, we will get as 1000 plus 0.3 means 1000 plus 0.3, we are getting as 1000.3 kilohertz, and FC minus FM1, 1000 minus 0.3, we are getting as 999.7 kilohertz. Similarly, we will calculate FC plus FM2 and also FC minus FM2. Here we are getting as 1000 plus 0.8, that means 1000.8 kilohertz, and also FC minus FM2, 1000 minus 0.8, that means 999.2 kilohertz, and the third one is FC plus FM3, 1000 plus 2, that means 1002 kilohertz, and FC minus FM3, we are getting as 1000 minus 2, that means 998 kilohertz. Now look the options which are the things are present. Okay, 997 is present, 1000.3, 999.2, and also 1000.8, 998 and 1002 kilohertz are present. So both 1 and 2 options are correct. Now 15th question. The depth of the modulation index, in terms of A maximum and A minimum. We know that modulation index M we can given as M is equals to AM by AC. AM means amplitude of the audio signal, AC means amplitude of the carrier signal. We know that AM, amplitude of the message signal or audio signal, means A maximum minus A minimum divided by 2, and also amplitude of the carrier wave we can given as A maximum plus A minimum by 2. Now we are going to be substituting here, we are getting the M value, that implies M value, M is equals to AM by AC. No, so AM means A maximum minus A minimum by 2 divided by AC means A maximum plus A minimum divided by 2. 2 gets cancelled. We are getting as M is equals to A maximum minus A minimum divided by A maximum plus A minimum. So which option is correct? Third option is correct. Now 16th question. If we see the amplitude of the carrier wave, m is the modulation factor, then the amplitude of the sidebands. Okay, they have said that already now only we have discussed in amplitude modulation, modulated signal is present. One is the carrier signal and another one is the upper sideband and another one is the lower sideband. And the amplitude of the carrier wave is AC and amplitude of the sidebands is m into AC by 2 amplitudes. Okay, they have asked that amplitude of the sidebands is what is the formula? M into AC by 2. So which option is correct? And here is amplitude is given as VC, no, m into VC by 2. So second option is the correct one. 17th question. If the carrier wave of amplitude 10 millivolts, they have given that carrier wave amplitude. This is the, let us consider FC. This amplitude is AC, they have given is 10 millivolts. And the audio signal amplitude AM and AC they have given is 10 millivolts, and the amplitude of the message signal they have given is 2 millivolts. We have to find the amplitude of the LSF or USF. That means amplitude of the lower sideband or upper sideband amplitude. Now only we have discussed amplitude of the lower sideband frequency, or that is equals to upper sideband frequency, that is equals to m into AC by 2 now only. So m means we can write as AM by AC, modulation index. M means AM by AC into AC divided by 2. AC gets cancelled. That means we are getting as AM by 2. AM means 2 millivolts. 2 millivolt by 2. That means 1 millivolt is the correct option. So third option is the correct one. Now 18th question. The amplitude modulated current is given by, this is the equation they have given, then depth of the modulation is, that means m value, depth of the modulation means m value we have to find. So the current modulated signal current equation they have given as I is equals to 125 into 1 plus 0.6 sine 2900 t into sine 10 to the power of 6 t they have given. Now we are going to be comparing the standard equation I is equals to IC into 1 plus m into sine omega mt into sine omega ct, modulated signal output. From here the question they have asked is depth of the modulation, m value they have asked. Now comparing these two things, m value we are getting as 0.6. in terms of the solution, in terms of percentage means m is equals to 0.6 into 100%. That means m is equals to 60%. m is how much? 60%. Now 19th question. The minimum voltage of the AM wave was found to be 2 volts and the maximum voltage is 10 volts. Then percentage of the modulation index. We know that minimum A maximum they have given is A maximum is 10 volts and minimum voltage is 2 volts. A minimum they have given is 2 volts. Question is find the modulation index, percentage of the modulation index. M we have to find. Now only we have solved the thing. M means A maximum minus A minimum divided by A maximum plus A minimum. A maximum is 10 and A minimum is 2 divided by 10 plus 2, 8 by 12. That means 2 3s, 2 by 3. Percentage means into 100. That means 200 by 3 means 66.7 percentage. So which option is correct? 19th, second option is correct one. Now 20 question. A sinusoidal carrier voltage of frequency is 1.5 megahertz. That means carrier frequency FC value they have given is 1.5 megahertz. 1.5 megahertz means 1.5 into 10 to the power of 6 hertz. We are rewrite as FC is equals to 1500 into 10 to the power of 3 hertz. It means 1500 kilohertz. FC value is 1500 kilohertz they have given. And the amplitude is 50 volts. FC carrier frequency amplitude AC they have given is 50 volts. And sinusoidal frequency is 10 kilohertz. And also FM value they have given is 10 kilohertz. Now lower and upper sideband frequencies in kilohertz are. That means USB upper sideband frequency and lower sideband frequencies we have to find. Okay, till now already we are knowing that we can write as this is the upper sideband frequency, this is the carrier frequency, this is the upper sideband frequency, and this is the lower sideband frequency. Upper sideband frequency means FC plus FM. Lower sideband frequency means FC minus FM. First we are writing the upper sideband frequency. USF means FC plus FM. FC carrier frequency is 15 kilohertz. That means 1500 plus FM means 10. That means 1510 kilohertz. And lower sideband frequency LSF FC minus FM. That means 1500 minus 10 means 1490 kilohertz. So which option is correct? First option is the correct. 1490 and 1510. Now 21st question. A transmitter supplies 9 kilowatt to the area when unmodulated. That means unmodulated power they are given is 9 kilowatts. Unmodulated power means carrier power. Unmodulated power is nothing but the carrier power. And carrier power we are indicating with PC. That is 9 kilowatts they have given. That means 9 into 10 to the power of 3 watts. Now the power radiated when modulated to 40%. That means modulation index they are given is 40%. It means 0.4. Modulation index is 0.4. We have to find the power radiated modulated. That means total power. Power radiated when modulated. After modulation we are calling as total power. The total power we have to find. We know that what is the formula? PT is equals to PC into 1 plus m square by 2. That means PC is there given is 9 into 10 to the power of 3 into 1 plus modulation index is 0.4 whole square by 2. That is equals to 9 into 10 to the power of 3 into 1 plus 0.16 by 2. That means 0.08. 9 into 10 to the power of 3 into 1.08. After multiplying 9872, 9.72 into 10 to the power of 3. That means we are getting as 9.72 kilowatts. Total power is 9.72 kilowatts. Now 22nd question. The total power content of an AM wave is 1500 watts. The total power PT they have given is 1500 watts for 100% modulation. That means M value is 100%. 100% means 100 by 100. We are getting as 1. The power transmitted by the carrier. We have to find the carrier power we have to find. That means PC value we have to find. Till now we have discussed total power. PT is equals to PC into 1 plus m square by 2. Total power they have given is 1500 is equals to PC into 1 plus m value they have given is 1. That means 1 by 2. 1 square means 1 only. 1500 is equals to PC into 1 plus 1 by 2 means 3 by 2. 3 ones 3 500s. PC is equals to 500 into 2. That means 1000 watts. 1000 watts. That means fourth option is the correct one. Now look here. In a diode AM detector, the output circuit consisting of R value they have given is a diode detector. The diode detector, the detector means for detecting the AM signal, the detectors are going to be used. These detectors are used in the output side. And for this detector, R value they have given is 1 kilowatt and capacitance they have given is 10 picofarads. The carrier signal of 1000 kilohertz, that means FC is 100 kilohertz, 100 kilohertz, it will be detected. It is good or not? That means this can be detecting or not, they are going to be asking. That means any detector, one of the condition it should be satisfy. The condition is 1 by FC should be less than or equal to RC less than or equal to 1 by FM. R means resistance, C means capacitance, FM means modulating signal frequency, FC means carrier frequency. They have given that carrier frequency R value. We can see this condition is going to be satisfying or not. If this condition is satisfying means yes, not means no. 1 by FC means 100 kilo, 100 into kilo means 10 to the power of 3 less than or equal to R means 1 kilowatt, 1 into 10 to the power of 3 into 10 pico, 10 into pico means 10 to the power of minus 12. So we are going to be calculating as 1 by 10 to the power of 5 less than or equal to 10 to the power of 4 means 10 to the power of minus 8. That means 10 to the power of minus 5 less than or equal to 10 to the power of minus 8. This is wrong. Okay, so it is not going to be satisfying. 10 to the power of minus 5 greater than or equal to 10 to the power of minus 8. So no. No means second option is the correct one. In FM system, a 7 kilohertz in FM system they have given that a 7 kilohertz signal modulates. That means FM they have given is message signal frequency they have given is 7 kilohertz. Is modulates 108 megahertz carrier, and FC carrier frequency they have given is 108 megahertz. The frequency deviation means delta value they have given is 50 kilohertz. The frequency modulation index we have to find. Already we know that amplitude modulation means AM by AC. Here ask the frequency modulation. Frequency modulation we are giving as frequency deviation divided by the FM. Frequency message signal frequency deviation divided by the FM. Now frequency deviation they have given this 50 kilohertz and message signal frequency they have given is 7 kilohertz. Now 7 ones 7 sevens, that means 7 point something, that means 7.143. Modulation index we got is 7.143. So which option is correct? First option is the correct one. Now look at the 26th question. The maximum useful frequency in the F region is X. That means the frequency maximum useful frequency in F region they have given is something FC I am indicating is X they have given. And when the critical frequency FC is 60 megahertz, maximum useful frequency they have given is X, and when the critical frequency is 60 megahertz, that means critical frequency FC they have given is 60 megahertz, and angle of incident is 70. Angle of incident theta value they have given is 70 degrees. what we have to find? We have to find the x value, that means maximum useful frequency we have to find. We know that maximum useful frequency in f region, the formula is critical frequency divided by cos theta. Okay, now FC already they have given that 60 megahertz, 60 into 10 to the power of 6 divided by cos theta is 70. So after substituting the values, 60 into 10 to the power of 6 divided by cos 70 value around 0.342. Okay, now 60 divided by 0.342, we are getting as 175 into 10 to the power of 6. That means 175 megahertz is the answer. So which option is correct? Third option is the correct one. 27th question. Suppose that the modulating signal is m of t. The modulating signal means m of t. M of t they have given is 2 cos 2 pi fmt. Message signal they have given, and carrier signal xc of t. Xc of t they have given that AC cos 2 pi fct. Message signal they have given that, and also carrier signal also they have given. Now, which of the following conventional AM without over modulation? Okay, now they have given that 4 options, and which of the following is not the over modulation? Modulation m is equals to 1 means critical modulation, and also modulation m is greater than 1 means over modulation, and m is less than 1 means we can receive. This is not the over modulation, where this is the useful thing, m should be less than 1. So in the question they have that without over modulation. Without over modulation means this is the thing, m should be less than 1. We have to check all the things where the m is less than 1. That is the correct one. So for checking, look here. First option, look the first option. In the first option they have given that x of t, they have given that AC m of t cos 2 pi fct. Now in this one, only the product of the message signal and carrier signal only present. There is no addition of the carrier signal, AC cos 2 pi fct. This is not the modulated signal, so this option is the wrong. And look the second thing. And in the second thing they have given that x of t is equals to AC cos AC into 1 plus m of t cos 2 pi fct. Now we compare this equation with the standard equation. X of t is equals to AC into 1 plus m 1 plus modulation m into m of t m into m of t means m of t cos 2 pi fct. If by comparing this is m of t, okay, 1 into m of t. So here is the m is equals to 1 is present, and m is equals to 1 means this is the critical modulation. This is not the over modulation. So this is option also wrong. M should be less than 1 is the correct thing. So now check the third option. The third option they have given is that x of t is equals to AC cos 2 pi fct plus AC by 4 m of t cos 2 pi fct. Now x of t is equals to AC I am taking outside. That means under AC coming 1 plus 1 by 4 m of t and cos 2 pi fct. Now comparing with this standard equation, x of t is equals to AC into 1 plus m into m of t into cos 2 pi fct. And comparing, here is the m value is 1 by 4. Modulation index m is equals to 1 by 4. This is less than 1. So this is satisfying without over modulation. So third option is the correct thing. Now look the fourth question. They have given that C of t and M of t are used to generate AM signal. The modulation index is 0.5. That means M value they have given is 0.5. That means 1/2. And the quantity P sideband, total sideband divided by the P carrier. That means we know that already we have to find PSB divided by P carrier we have to find. We know that total power is nothing but the sum of the carrier power plus sum of the sidebands, total sidebands. And PT is equals to, till now we have discussed PT is equals to PC into 1 plus M square by 2. So from here PT we can write as PC plus PC into M square by 2. And this comparing these two things, PT is equals to PC plus PSB. From here PC means PC, PSB means PC into M square by 2. No, now we are going to be substituting here. Now PSB divided by PT, P carrier is equals to PSB means this is the thing, PC into M square by 2 divided by P carrier means PC. PC gets cancelled. Already M we are getting as modulation index means 0.5, 1/2. 1/2 whole square divided by 2. That means 1/8. 1/8 is the correct answer. So first option is the correct thing. Thank you.